Now, let's look at two examples of how white space affects code readability. Both of these modules perform the same operation, adding two 32-bit values and generating a sum and carry out. But one follows good formatting practices while the other does not. So let's look at the first example. What do you think is wrong with this example? One, everything is crammed together, right? Making it harder to read. Number two, there's no clear separation between your inputs and outputs. Number three, the always underscore comp block is on the same line, making it difficult to spot logic at a glance. And lastly, the lack of indentation makes debugging and maintenance harder. So while this code is syntactically correct, it's difficult to read and maintain. Now let's see a better version. Okay, this is our second example. So what do you think makes this particular block of code better? Well, number one, there is a clear separation of module ports. You can tell which ones are the inputs and which ones are the outputs, right? Each input and output is properly spaced. Number two, there is proper indentation. This improves readability and makes it easy to follow the structure. You know where the ports are, you know where the procedural block is, and so on and so forth. Okay. Number three, there is logical spacing within the always underscore comp block. Assignments are easy to find and modify. Number four, it's more maintainable. If you come back to this code later, it will be easier to understand. So both versions of the code do the same thing, but the good example is far easier to read, debug, and maintain. By using proper spacing, indentation, and formatting, we make our system Verilog code cleaner, clearer, and more professional.